Welcome to the Databricks Skill Builder series. We're glad you're here.
All right. Well, thank you guys for coming today. My name is Robert Mosley. I'm Solutions Architect here at Databricks. Today, I'm speaking about generative AI. More focused on LLMs, talking through LLMs on Databricks. What are the strengths of Databricks around LLMs, and then we're going to demo a solution um, on Databricks and get to see what some of those products look like. If you have any questions, as she said, feel free to put them in the chat. I'll get to them when I can. Happy to make this interactive and have whatever Q&A either you see or you've been hearing in the landscape, that kind of thing. So today, as I said, I want to cover the Lakehouse for anybody who may not be super familiar with Databricks to understand our position and where we're coming from, what our mindset is and our perspective. Then we're going to look at generative AI within Databricks, and then we're going to look at a demo around RAG architecture. That's a bit of a technical term. I'll go ahead and define it now. It means retrieval augmented generation, which once again is another technical term. You're like, that doesn't help me at all. It's context stuffing. So it's basically providing information along with the prompt to the LLM, so that the LLM is going to be more likely to give a better answer with fewer hallucinations and things like that to help the LLM basically understand the information a little bit better. It'd be almost like asking a human being who is really good at using a reference manual a question, and then them using that reference manual to be able to answer your question. That's what the LLM is essentially doing in this type of architecture, but we'll get into it later. So looking at Databricks and the Lakehouse in the landscape, there's this general sense of a data maturity curve that different companies are on. Largely, for the last several decades, people have lived over on the left. They've really just wanted to know what's happened with their data, what's happened with their business. So they build out data, maybe from an ERP system, and then they build reports on top of that. They might have ad hoc stuff that they do and exploring it to get a sense of their business. But everything is very historical in nature. It's asking the question, what happened? More recently, over the last decade or two, data science has really gotten a hold on the landscape. People are no longer just asking questions about the past, but they're asking about the future. They're wanting to become predictive, what's going to happen, and then taking the steps beyond that. How should we respond? Can we automate these decisions? I take this to be, maybe we're monitoring sensors flowing from a factory, and we understand that this machine is about to break. How should we respond? We need to replace this gasket because it's about to go down. Or it's about to falter. And then what should we do about it? How do we automate that decision? We create a work order when the maintenance crew is available to go and fix it before it breaks down. And so they're able to address it as part of a normal maintenance cycle. You don't have any downtime, and your factory is able to run more smoothly. The situation with this is that classically, everything that's done on the left has been done with a data warehouse. It's structured data. You know what's flowing in. You know how to work with it. Lots of times it's built nightly. Sometimes it's built hourly, but it's not always real time. It's actually rarely real time. The stuff on the left, that really comes into this data lake world. Lots of unstructured data, different tool sets, different tech stacks all together. And those two worlds don't naturally always work together. There inevitably comes a time where the data scientists look over at the data warehouse and say, oh, you've got nice, clean data. I could really use that. And then they integrate it over. And then eventually the data scientists build something that people want to report against. And so then they're migrating that data to the warehouse. And so you have this interchange of information. And then it becomes very difficult to govern that, difficult to manage all of that. And you end up with these two different worlds that become very incompatible with each other, and has this overhead of costs just to be able to support the integration between these two worlds. And so that's really where Databricks came in with the Lakehouse platform. The Lakehouse was something that we came up with, that that was the term that we coined, and we've built out something that's very successful in that space. And so what you have is, it has that base layer of that cloud data lake that people are used to working with in the data science realm. Has structured, unstructured data, stretches across any of the three clouds. But then we added that Delta layer on top of it. And what Delta does is it really takes your data and makes it act like a database. It allows for concurrency, gives you ACID transactions, things like that. The Unity catalog came in as a way to provide that governance, that security layer. It took that data lake security, which was really difficult to manage, made it similar to a database layer, but then even took it to a level beyond that, allowing for technical lineage, allowing for Unity to get insights to understand who's using your data, why, where's your data going, where did it come from, using that for both structured and unstructured data, as well as moving into the AI and model space, really give you a great understanding of how your data landscape is built out. Together, these three capabilities really support the four main use cases: data warehousing, data engineering, data streaming, data science, and ML. Most products that you're going to look at in the data space are going to fill one of those. We really have targeted this Lakehouse platform to be able to support all of this, all of it together. Overall, it makes it something that's very simple, and reduces the complexity. We're also very open in how we plan things. Not only are we across all the clouds, but we also play very well with others. Just because we've built this lake doesn't mean that we block out other vendors. If you have your own enterprise catalog you want to work with, we integrate with those really well. If you have your own data warehouse you want to attach to, we can interact with that. If you have your own reporting tools like Power BI or Tableau, they integrate in extremely naturally. Everything is open and extensible for whatever use cases you have. Today, what I really want to focus on is this data science and ML. Everything that we've built in this Lakehouse is around this sphere. The founders were very AI and ML specific when they were creating Databricks, and they found that they needed this whole platform to be able to support AI and ML use cases naturally. And as they built this out, it became something that became very natural for generative AI as this has exploded in the landscape. The Lakehouse not only supports data science and ML generally, but it supports generative AI specifically. So I'm going to build out this slide here rather than go through it one at a time. This really highlights how that Lakehouse platform really helps set you up well for generative AI across the whole platform. Because generative AI isn't just about having an LLM, it's about having the supporting architecture for your LLM solutions. The LLM just becomes a cog in an overall solution that you're building out. So, starting from the very beginning, ingestion, LLMs really become better when you combine them with your data. They're far too general, usually for most business applications, without combining it with your data. So you need a path for ingesting your data, both structured and particularly unstructured when it comes to LLMs. And that's a natural part of our Lakehouse. So being able to ingest that in, build out your bronze, silver, gold layers, getting that cleaned and refined and ready for use. And then also governing. With Unity Catalog, we've become a very strong product in the governance realm, being able to control not only the data and who has access to what, but also your AI models, to be able to secure and provide fine-grained access controls as to who's able to access your model solutions, things like that. Additionally, with Delta sharing, once you've built these things, you can share them both internally, but also externally. And even with the marketplace, you can make it available for subscriptions and to monetize your solutions. And then lastly, like model serving, that's also a key component of all of this. It's a fairly new capability that we released, but it rolls right into this. Being able to support not only CPUs but also GPUs for model serving allows you to be able to host and run your own open source models, even if you are using OpenAI or SaaS solution. Once again, if you're incorporating your data into it, being able to stand that up on an endpoint to abstract away from that SaaS solution, and to encompass all of that logic in a model serving scenario, it really helps take the load off and give you something in which that you can serve to your customers. So the Lakehouse AI platform, it works for all of AI. Deep learning, if you're working with PyTorch or TensorFlow, also all the classical ML algorithms. If you've ever touched data science, you've worked with scikit-learn, you've worked with XGBoost and all of those types of libraries. You know that Databricks works well with them. Also works really well on the generative AI side, both proprietary LLMs, that SaaS model, but also open source LLMs like what you would find with Hugging Face. So whether or not you're choosing ChatGPT or Bard or Hugging Face, we don't really care. We can work with you to make sure you're able to choose the best model that you need for your use case and help you deploy it. Maybe you're prototyping with OpenAI, but then once you're ready to scale, you need to reduce costs. And so you want to fine tune an open source model. We're here to help you be able to do that and then to be able to swap between them. We make it really easy. We keep you very flexible. We help you keep your options open. And then lastly, with the chains, being able to work with all those agent structures and LangChain and things like that, we naturally integrate with all that. Makes it really easy for you to build and extend your solutions on Databricks. Really want to stick to these that third and fourth pillar there, the proprietary and the open source LLMs. A lot of customers really worry about that. Which side should we fall on? Is Databricks on one side or the other? Even if a customer has chosen that hey, I know I'm going to work with OpenAI. Why do I need Databricks in that situation? I really wanted to help speak to that in different ways. One is no matter what LLM you choose, you still need a supporting architecture for it. As we were talking about, LLMs don't really work all too great without adding in your data, without incorporating your data into it. If you want to use ChatGPT for your math homework or to write an email or to write a haiku, it's great for all that. But if you wanted to ask a question about your business domain, you've got to bring your data into the equation. And that's where you're going to need an AI platform to be able to support that. So when it's ingesting your data, preparing it, building out a model to incorporate it, serving that model, and then monitoring the results to make sure it's healthy and performing the way that you want. Databricks is there to help you the entire way around. Make sure you're successful in being able to handle all of that. Secondly, this is a new area. This is growing very quickly. This industry is not changing, it's staying the same. It's not static. We don't know who the big players are going to be a year from now. On the open source side, we've seen that where almost every month a new model has taken over. At first, we were talking about DALL-E. That was our contribution to the market, an open source, commercially viable product that companies could make use of. We put that out there really to challenge the status quo and to say, look what you can do. We put out a data set that allowed people to train regular models and turn them into that instruction-based type model, like that ChatGPT type integration. And people stepped up. We saw Mosaic ML release their models. We saw Falcon be leader for a while, and now Llama 2 is the talk of the town. This is an area that's constantly changing, constantly improving, and it's going to be one of those that you want to be able to remain flexible on. You don't want to get too ingrained with one solution and to be able to upgrade. And the same is going to be true with proprietary LLMs. ChatGPT is definitely the industry leader at the moment. But Google has been making strides to catch up. There's a lot of other players that are involved. In 2 or 3 years, it may be completely new companies that work to step in. You don't want to get too ingrained with one architecture that keeps you from being able to have the options to move over. And with Databricks, that's exactly what you get. If you need to swap between models really quickly, we can do that. We have different products that help you abstract between them so that it becomes just a configuration change. And that's what you want to see in a space that's like this, that's not very well defined yet. So at Databricks, we are transforming Databricks with LLMs in 2 different ways. One, we're transforming how you build LLMs with Databricks. So we're including products into the platform that help you build your LLM solutions faster and easier. Vector search. This will allow you to very quickly create a vector database with all of your text data so that you don't have to bring in a third-party vector database for that. GPU model serving. So we're extending our model serving solution to GPUs. This allows you to host open source LLMs so that you can get them available quickly and then interface with it through an API, just like you would with OpenAPI or OpenAI. And then also we're building out curated models from Databricks. This will be available in the marketplace. And what it does is it's essentially us going to Hugging Face. We understand that this landscape is changing constantly. And what we'll do is we'll curate a list of high-end models for specific use cases so that it really cuts through all that noise and helps you find the model that you want to work with and deploy it on Databricks much faster so that you don't have to do all that research, take all that research and time to figure it out. And then also AutoML for LLMs. So we're going to make it super easy with AutoML, just like you have it with some of your classical scikit-learn type models. Now you'll have it with your LLMs. You basically just point at the data that you want to fine tune on, and we'll help you fine tune a multitude of models that you can then evaluate and determine which one you want to use and which one works best for your use case. We're also transforming how you use Databricks with LLMs. So on the left side is the products that we're building to help make it easier for you to build LLMs. On the right is how you can do everything easier because we have LLMs built into the product. What I'm showing you here is the AI assistant. It's in the product today. You might have seen demos for Lakehouse IQ from our Data and AI Summit. That'll be sort of the upgrade to this, but it's incorporating that chat-like aspect inside the product so you can have it help you debug your code. If you've got an error, you can ask it to just write fresh code. And then with a click of a button, you can push it over into your notebook and start running it over there. And so that type of interaction really speeds along the process. So today for the demo, and then I'll pause for any questions that came up. Well, I'll go ahead and pause for any questions now. Did any questions come up, Stephanie?
And not yet.
Okay. All right. Sounds good. So if you have any questions before the demo starts, go ahead and throw those in. And I'll pause before I jump over. But today for the demo, we're going to look at, as I said, that RAG architecture, retrieval augmented generation. I like to refer to it as context stuffing because that's exactly what you're doing. What we have is we're going to start with an ingestion pipeline. We're going to take your domain text. In this scenario, it's going to be PDF documents. And we're going to create embeddings off of those PDF documents. And we're going to stick them in the Delta Lake, but we're going to create a vector search index off of it. And now the code that I'm taking, starting with, it actually is using a different vector database, Phase, which is a Facebook vector database. The code was written before Data and AI Summit when we announced vector search. So what I'm actually going to do is I'm going to show you how you can go from that Phase database and then use the vector search in Databricks. This is probably the area that if you use one of our solution accelerators to get you in this is the one thing that you'll have to change. One, you'll have to point it to the files that you have in your data lake that you want to ingest. And then 2, you'll have to decide on a strategy for your vectors and where you're going to store your embeddings for your vector database. And so showing you this, walking you through the code that it would take to create a vector search index. If that's the path that you want to go, that's the type of work that you would need to do anyway. And so this will be a big area of focus of the demo. So that's the first part. And then what it is, it's building out that MLflow model. So what this model will do is it'll actually receive a prompt. So when a user submits a prompt, that model will receive that for inference. Instead of going directly against the LLM, which is classically what's going on in a chat GPT type scenario, we're doing a similarity search. So we take that, we generate the embeddings for that prompt, we pass it into the vector search database, and we come back with some matching documents. All that sounds really technical, but with the LangChain libraries that we're using, it's just a single couple commands that you got to execute to be able to do this. So what it does, it basically does a lookup, and it finds PDF documents and text that match what the prompt is about. So if the prompt is about blueberries, it's going to find text about blueberries. If it's about acetone, which is the demo that I'm showing you today, it's going to find text about acetone. It then embeds that information into the prompt. And so you would apply it to a template. And what that ultimately looks like is now you'll have like an instruction. Maybe that instruction says, hey, based on the information below, answer the question that's provided to it. The user only submitted the prompt. We've built out this entire thing as a new, this is the prompt engineering aspect, as a new prompt that will go to the LLM. So we'll say, based on the information below, answer the user's question, and the context will be from this database. All of that information will go to the LLM. In this scenario, we're using Llama. And then that will be send a response back. MLflow will handle that, and then that model's response overall will go to the user. So this entire thing here will be packaged up into a single MLflow model, and then we'll be able to deploy that entire model on Databricks GPU model serving, so that it becomes super simple to deploy and then use. As I say over here, this type of architecture is really great for reference material, documentation, user manuals, support tickets, anything that you have that's really domain specific that you want to be able to roll out to your customers or to your internal users as well. So with that, if we don't have any questions, I will go ahead and pop over into the demo here. What I want to show first and foremost is the UI that's on top of this. So the way we built this solution accelerator, it's being hosted in Hugging Face's Spaces. It's something that you have to be approved to access it. So don't try to follow this URL and get to it. But this is showing similar what type of UI you can build really quickly on top of an endpoint solution after you've built it. So as you see here, I've written out a question already. I submitted it. What happens if I get acetone on my face? The answer that came back, acetone can irritate the skin, including the face. If you get acetone on your face, it's important to wash it off immediately. Just so you see response time, I'm going to go ahead and submit it again. So it ran fairly quickly, gives you your response over here. One of the things that's really beneficial with the RAG architecture is because we have that lookup aspect. Not only do we pass that information to the LLM, but you have that information available to pass to the end user. And so as you see here, this used these PDF documents to be able to answer that question. So if I had further questions or I wanted to verify that the LLM wasn't making things up, I can go and explore those documents to read and learn more. All right, so with that, I'll go ahead and step over and into the code that we've got. So this, as I said, is a solution accelerator that I've pulled in. This is where it's available. I've incorporated it into the demo that I'm going to show you today. I need to bounce into a different folder real quick. This is a copy of it that I have. So this is the one that I wanted to show. So pulling it in here, then you're able to work with this solution accelerator. It's really easy to add into your repo. I've copied it over into my workspace so that I can modify it and not risk needing to push changes or anything across. But being able to pull it down, work with it. This is really just giving a highlight overview of what we're doing. So the intro slide has no code. It just talks through the overall solution, tells you where you can go and you can update configurations. We may step into that just to see what some of the configurations look like. But the meat of what I really want to show you, as I said from that prior picture, is this top part, this ingestion pipeline, because that's the biggest part that would need to be tweaked for someone who's wanting to build out a solution rather quickly using the accelerator. So this is what the code originally has. As you can see, pulling in a whole bunch of libraries, pulling in the configs, and then looks like this got run after I last ran it. So it's just getting that it's clearing out the database that exists there now, that vector database. And then what you have here is you just have a couple of functions that are defined to extract metadata out of the document. What it's really doing is it's pulling the chemical name out of the document. So that might be different too, based on what files you're ingesting and what kind of metadata or information you might want to parse out. You may not want to parse anything out. But then what you see in this code, this actually does everything about pulling out all that data from the entire data directory that we're pulling from, parses through all that metadata, builds out a bunch of information, enumerates through it all, chunks it out. So when I talk about chunking, one of the things that you'll notice when we look at the sources is that you see the same file represented multiple times. What we're doing with chunking is it can be expensive, both from a computation perspective and from a dollars perspective, to send large files to an LLM. And so a lot of times there's no need to send a huge text of huge amount of text to an LLM. Usually you just want pieces of it. So what we do with this chunking process is we take that huge document of chemical information and we break it up into chunks. You can apply basically some configurations to it to both determine how big are those chunks and how much overlap do they have, so that you don't break it off right in the middle of an important sentence. And then we build out the vector database with those individual chunks there. So what you see here when it's providing the exact same source multiple times, it's actually finding multiple chunks of information from that document that it found were relevant, that it supplied to the LLM for the LLM to read and consume. And so that's what this code is doing here, is it's actually breaking it up into those chunks, and then putting those chunks of information into that phase database. And so that's what you see down here. It's creating that vector database, and it's saving all of that PDF file information out there. This is a bunch of test scripts just to make sure it's able to access that it can do a similarity search. So you see here, someone is asking what happens with this kind of chemical exposure, and then it's matching on certain documents and returning it for people to see. And so that's really just there for testing that it exists and using it afterwards. So that can work out real well if that's what you want to do. What I wanted to show you is, okay, so I have that, but I don't want to use that solution. I don't want to use phase. I want to use Databricks vector search. Oh, we got a question.
Sorry, jumping in here. If we were going back to talking about the chunking piece, we have a question for that. It says, how would an LLM understand technical keywords, acronyms, serial numbers, and how should we handle that?
That is a very good thing to think through. If someone wants to be able to ask very detailed information like that, one, you need to be able to provide sort of either a definition or something of that nature to it, or you've got to break it out into like specific metadata. So as you saw in that last example, and that's also in this example, we had those extract metadata aspects. So what it's doing is it's going out and it's finding the common name inside the document, and it's pulling out that common name, and it's defining it as a name so that the system knows what chemical is being applied here. So if you have lots of scenarios where people might be applying specific acronyms that maybe only your organization has, there's solutions that you can do, especially if you have a business glossary of some sort. So this is really where it's going to help people shine if they have a good data governance process. Because if you have a business glossary defined, that helps you take those acronyms that are commonly used in your business and turning it into business information, then you can include that in your vector store so that if somebody asks for something that's very specific and it's an acronym, it actually matches on a business definition of that acronym, and it can provide that back to the LLM. So now the LLM has context as to what does that acronym actually mean, while it's also looking at information that can help answer the person's question. And so it provides that kind of context for the LLM. So that's where you can start looking at this in terms of, almost look at it like you're training a new employee. Maybe you hire someone who's really smart, but doesn't know your business domain. That's the type of thought process you should be thinking of when you're thinking, what kind of information do I make available in a vector store that I make available to an LLM to be able to consume so that the LLM can make decisions off of that. There's also another architecture type with LLMs called agents. That would be something to look into. In that situation, you basically allow the LLM to be able to have almost a conversation with the orchestration engine. So right here, this is sort of one way the orchestrator builds out a prompt, submits it to the LLM, and sends it back. An agent type architecture allows for a conversation. So the LLM can almost ask for information. The orchestrator can go and look up that information and supply it to the LLM. The LLM can ask back for more information, and the orchestrator might go to a different source to get that. All that needs to be sort of pre-configured. That's what LangChain, that agent chain, can really help with for some LangChain type solutions. And so it's a different architecture. This is probably more common than that, but that's one area you can go down if you find that kind of information retrieval becomes more complex than just being able to use a vector search. Long-winded answer for that, but those are a couple of ways to approach it. So coming back over here, I want to build out my solution now to use Databricks vector search. I could also point to a different directory. I'm not going to do that. I'm going to use the exact same solution in this situation. You can see, once again, we're using LangChain in this situation. LangChain really helps with a lot of this, has a lot of libraries that make this really simple and straightforward. I'm using those same extract metadata methods from before, which are optional for your solution. I'm pulling in the exact same directory to get those PDF documents. And I'm going through a lot of the same parsing mechanisms. But instead of immediately taking it and throwing it into the phase database, what you see here is I'm actually dropping it into Databricks, into the Delta Lakehouse. So this is landing in Unity Catalog in this table. And in that table, you can see the results, right? So I have my my text and my source, and then that metadata, that key name that we were able to pull out. And so through that source, you can see the text that's provided here. You can tell it's fairly long and extensive, just like what I was talking about. So I'm going to show that that chunking in more detail here. So pulling out an example of that long text, this is that chunk function here that's going to chunk it out and break it out. This is where we can set the configuration options for how big it is and how much overlap do we want. And you can see up here with just some of those examples provided how it took that long document and broke it out into multiple chunks. So we're going to apply, this could be all wrapped up into the config if we would want, or you can hard code it as we've done here. But we're going to run this through a couple of functions and we're going to build out our chunks. So whereas before we had an individual file with all the text in it, now you see that we have those files out there repeated multiple times, 40s out there, or 3140s out there twice, right, for ASF8. But there's two different chunks for it that has been broken up into. And then we're going to drop that chunked data into a Databricks table. Now, if creating that vector database is intimidating for you, it doesn't need to be on the Databricks side. It becomes super simple to take a Delta table, to take that text information that's stored in a Delta table and to turn it to a vector index. So what you see here is I'm importing in the vector search client. And then I just run this command. I tell it what source table I want to pull from. I tell it what the destination table or destination vector search index name should be. I tell it what my primary key is, that ID column, which is the source or well, it should be the source file. And then the index column is the text. So pulling that text item right there. And then must have renamed that after a bit. But then the embedding model endpoint, this tells us which LLM we're going to use to create those embeddings. And so we're pointing at Llama version 2 13b chat, which is hosted internally on Databricks here. And so, yeah, we build it out like that, and then that would be our Databricks solution that we can work off of. And if something like that isn't something that you're super familiar with, that's great. That's where this Databricks assistant really comes in. You know, I wrote out here similar things as if, you know, let's say someone is a Python developer, but they're new to Spark, but they wanted to use this type of solution. So I can say, you know, how I got my data frame, how do I write it to a Delta table? Well, this tells you how to write out to a Delta table. And so then you can come in here and you can apply that same type of information to it. And then it's like, well, what if I have a Pandas data frame, not a Spark data frame? And then it shows you how to go about changing from a Spark data frame into, or from a Pandas data frame to a Spark data frame, and then writing that Spark data frame to a table. So you can use the assistant to help you with that kind of thing. And if you wanted to just throw the code over there to assist you with it, you can just click on that and the code's over there, and then you can run it as you would desire. So with that, I'm going to step over. I'm going to go through some of these others rather quickly. This one is just testing. That's all it is. They're testing, doing the lookup against the phase database. And so you'll see, you know, they're using the Hugging Face pipeline. They're building out all this process to be able to do a retrieval search. And then they're testing out that not only retrieving that, but then passing it into the LLM. So, you know, they've got some test questions here. What issues can acetone exposure cause? What's the difference between nuclear fission and fusion? What should we do if OSHA is involved? This is probably a fun query because the vector database has nothing to do with this. And so the LLM will still try to answer the question, but this is a great use case to throw at it. You know, what happens if someone asks a question for which I don't have good information for it? So, you know, throwing wildcards into your tests to be able to play with it. So creating the ML, this is the next big step. So what we're doing here is, if you remember, this entire solution here is wrapped up into an MLflow model. That's what we're going to create. We're going to create an MLflow model that does all this logic, does the similarity search, applies it to a template, sends it to an LLM, gets the response, and sends the response back to the user. Fortunately, this is really easy in MLflow. MLflow has this capability where you can extend this object, and you can then apply a lot of pre-processing and post-processing to model inference. A lot of times, and you might think of it this way, with MLflow, you build a model, you register just that model. And then when you deploy that model, you have your inputs and your outputs from that model. What this allows you to do is this allows that model to be a part of the overall solution. So as you scroll down here, you'll see that the key piece here is this predict method. So this predict method is what gets called during inference for this model. And instead of it just going to an LLM or just going to a model endpoint, it now supports the pre-processing and the post-processing that occurs in here. If you'll look right here, this is actually the call to the LLM. It's wrapped up inside this LangChain library call, which submits the question to the LLM or to the whole process. And so what's going on in here is we're building out that chain. It's defining how many documents do we want to get back for a response. That filter, if you remember, we have the ability to apply a filter, so you can type in a single chemical if you want to filter down to a narrower chemical range, and it'll apply that filter to the results. And then so it basically builds out that entire QA chain that's going to do that similarity search and everything. What this model is expecting is it's expecting some things to be passed in upon init. So we'll look at that when we actually start using the model later on, the types of things that are passed in, but like retriever, the Hugging Face token, the chain and aspects like that, or the chain gets built out, I should say, from all this stuff. But what you see down here is the actual build out of that chain, the use of it to be able to get that information. So some things are wrapped up in some smaller methods. So this is getting that context, and it's applying the information to the template. So it's getting the template from the config file. So if we hop into the config file, you'll see what that prompt template looks like. And then it's applying things like the context that's looked up from the similarity search, and then the initial question that the user provided. So all of that is encapsulated inside this logic here, but the net result is just this call. And once again, that's the LangChain call that does the similarity search, builds out the template, passes it to the LLM, gets the response. So the response that comes back has the actual LLM response bottled into it. And so that's why it's packaged as the answer. And then we also have source materials. So those were the documents that were found in the similarity search. And so it adds those to the source. And both of those pieces of information are what's returned. And once again, when we look at the results here in our UI, that's what we see. We see the answer, which is that prediction, but then we also see the source material available. So we're able to see that all the way through. So once you've built the model, now you need to assemble it all together. And so this is the part that calls that model. It's testing it out in that regard and everything that you would need for it. So we built out the object that basically allows for that model. We haven't registered it into MLflow yet. So that's what we're going to do. We're going to instantiate one of those. We're going to instantiate the model by calling the library. And then we're going to pass in certain pieces of information. So we're going to pass in the retriever, and what that does, that's doing the similarity search and retrieving those documents. We're going to pass in some configs that tell it basically what LLM to use. And then we're going to pass in our token, which basically authenticates and says I'm allowed to use that llama model, or I'm allowed to download that llama model, really. What I've shown up here is this is the original code that was written. So this here has them using the phase database to do a similarity search. What I've started stubbing out and haven't finished here, but setting up more as an activity for the viewer is incorporating that vector search. So this is the code here that would be replaced with vector search to be able to do a similarity search against vector search. So this is the type of thing that would replace that. So where this retriever gets set, that's using the phase database, we would use the retriever here that's using vector search, and then that's what we get passed through into this aspect. So once again, they're packaging up. You got to have certain libraries that would make this work. But the next step here is when we've instantiated this object, we're going to log that object, that new model, to MLflow. And so we're using that object that we instantiated up there, that instance of that model, and we're providing a registered model name. This is the path that we want it all to go get deployed to, but that model name that's sitting out there, that's the key thing. And then this gets logged into MLflow. And what this is doing down here is it's taking the most recent version of that. So whenever you log it to MLflow underneath the same name, it's just getting registered as a new version. This is going out to that new version that's just been registered and sets it as the production version. And then this down here is just testing it. So we're pulling the model, getting the most recent production version, which we just set right there. And then we're going to do some calls against it to get some questions about acetone, these other types of pieces of information, and see what the answers are. There's code here as to how to programmatically deploy the model. This is going through the API. This is probably necessary for CI/CD type processes, but with the UI that we have, it's not completely necessary. So I'm going to show how you can just deploy the model within Databricks. So first, I'm going to go to the models page here, and let's see if I can remember the model name that we're looking at, the MFG accelerator. So as you see, there's lots of versions of this accelerator. I think I clicked on the wrong one. Yep, this is it. So there's lots of versions of this accelerator that we're working with, the MFG LLM QA bot. You can see that they've each been replaced by the subsequent ones. So the most recent one is this version 7. So when that code was run, it was deployed here, and it's the production version. What you see also is that this has already been deployed on an endpoint. So that's on the model serving side. Instead of clicking on it, I'm going to go and find it. So coming over here, searching for QA bot endpoint 2. So we see that it's been deployed over in this area. If we wanted to create a new one or to edit this configuration, you can see how it's all set up. You can basically add a model. We're going to do the QA bot once again. Confirm. You can see how you can choose a different version. We're going to choose the latest version. You can choose the type of processor that you want. Right now it's GPU medium. You could also choose a multi one if you need the horsepower to be able to support it. And then you can choose small, medium, or large for what you need to work with. Then you can also split up the traffic. So if you want to do A/B testing, you can set up 90% of it to go to your old version and 10% of it to go to your new version, or vice versa, whatever you want to do to be able to support all of that. Yeah, so this is model serving. The endpoint that you would go against is this endpoint right here. You can copy that out, and then you can make calls against it. And that's actually what this app is doing, is it's using that endpoint to pass in these questions and to get these answers back to you. And it makes it that simple all the way around to be able to build and deploy. You can also come out here and you can see your utilization over time. You can see our requests that are coming in, the response times, the health and of the system, how it's getting pushed and everything. One of the benefits of this is that this does auto scale. So As your usage grows, this scales out and scales down so that you're not paying for unnecessary amounts of GPUs, but you're also able to support spiking traffic to be able to facilitate everything. So that really wraps up a lot of what I wanted to show. I don't know if we had any other questions come in while I was showcasing some of this, but really just to recap what I was showing here, you have the prompt coming in, and then what we've done is we had this whole MLflow wrapper that was wrapped around all of this here, and that facilitates doing the similarity search against a vector search, stuffs a template with that context, sends all that to the LLM, and then the LLM is able to give an answer that's more educated than it would if you were just trying to ask an LLM. And so this allows us to be able to take domain-specific information, incorporate it into our LLM's information pool so that the LLM is able to appropriately answer it. And then we're also able to see how all this gets hosted on GPU model serving, and how quickly and easily we can deploy an MLflow model to that. For next steps, some of the key things that I'd like to show here, I'll slip back into slideshow mode. One is there's lots of things that are coming out. So as you can see, there's lots of new features and stuff to stay in touch with. So there's evaluation tools, there's incorporating LangChain, there's the SQL AI preview, just all sorts of stuff that you might want to stay in touch with. Talk to your SA, talk to your AE, know what's coming down the pipe, get incorporated, get added to whatever private previews you want to be. The two that we really discussed today were vector search and GPU model serving. If you're working with OpenAI, you really only need CPU model serving, but you still might want that vector search to be able to build out that RAG architecture. So those would be two things to reach out about and try to get approved for. Today for resources, I'm including the one that we worked on today that uses Llama in the background. For those RAG examples. There's also an OpenAI one that you can use and work with that. It also uses Phase as the vector search database on that one. And so you can take what you learned today and apply it to either of those. You can also fine tune a Hugging Face model on Databricks if you want to go into those directions. There's a lot of blogs that are on these types of materials. Feel free to read through them, learn as much as you can as you start to look at your use cases. And when it comes, some of the follow-up steps, as I said, GPU model serving and vector search. But when it comes to your world and your use cases, work with us, talk to your AEs, talk to your SAs. We'll help you curate those lists. We'll help you decide which ones you can move quickly on, which ones take a little bit more time to work through. We'll build out a strategy with you to help you deploy. Anyway, thank you. That is all.
Thanks, Robert. This has been great. And I answered a few questions in the Q&A, but they were more around asking for the recording and whatnot. So we should be good. Thank you so much for your time today. This was really great.
No, you're welcome. Thank you.